Now come to particular integral when the right hand side function x is your small x to the power m into capital V, where this V is any function of x. See here, if V is of the form if e to the power ax, then x becomes e to the power ax into x to the power m, and the particular integral can be calculated as we discussed earlier. See our earlier thing. See it. I think it was not studied earlier. See, first is this one, and then after that x to the power m into v. See, when the function x is of the type e to the power x into v, where v is any function of x, then the pi is evaluated f dy, then pi will be 1 upon f d e to the power ax into v. Then we write it as equal to e to the power x into 1 upon f d plus a v, where this a is in e to the power, the a is in e to the power ax. So suppose this v is x, so this will be 1 upon f d plus a x. Now it will be clear with some example. See here, solve d2y by dx2 minus 4 dy by dx plus 4y is equal to x into e to the power 2x. See here, your auxiliary equation will be m square minus 4m plus 4 equal to 0. It means it is m minus 2 whole square is equal to 0. Therefore, m will be 2 and 2. So the complementary function will be c1 plus c2x e to the power 2x. Since we have two roots and the roots are same, equal roots. Now for particular integral, we have y is equal to 1 upon d2 minus 4d plus 4 x into e to the power 2x, d2 minus 4d plus 4. See here, it can be written as 1 upon d minus 2 whole square x e to the power 2x. Now this is of the type e to the power 2x into x. So we will take e to the power outside of this. So it is equal to e to the power 2x into 1 upon d is replaced by d plus a. Here a is small 2. So d is written as d plus 2 and the rest is minus 2 whole square over x. So it is equal to e to the power 2x into plus 2 minus 2 cancels. So it is 1 upon d2 x. 1 upon d2 means integrate this function x twice with respect to x. So this is equal to e to the power 2x. First integration of x will give you x square by 2 and the another integration will give you x cube by 6. So this is our particular integral. Therefore, the complete solution will be y is equal to complementary function plus particular integral. So it is c1 plus c2x e to the power 2x plus x cube by 6 into e to the power 2x. This is our complete solution. See another example. Solve d2y by dx2 minus 2 dy by dx plus y is equal to x square e to the power 2x. See here, this is also of the type e to the power ax into v type. So here the auxiliary equation is m square minus 2m plus m1 equal to 0. It means it is m minus 1 whole square is equal to 0. So m will be 1 and 1. Both roots are equal. Therefore, the complementary function will be c1 plus c2x e to the power x. And the particular integral is equal to 1 upon d2 minus 2d plus 1. We see here d2 minus 2d plus 1 x square e to the power 2x e to the power 3x. So it can be written as 1 upon d minus 1 whole square x square e to the power 3x. So it take e to the power 3x left hand side. So this is equal to e to the power 3x into 1 upon d is replaced as d plus 3. This 3 is from e to the power 3x minus 1 whole square x square. So it is e to the power 3x into 1 upon d plus 2 whole square x square. Now take common here 2. So e to the power 3x into 1 upon 2 square will come out. So it is 4. 1 plus d by 2 whole square x square. So it is equal to e to the power 3x by 4 into 1 plus d by 2 to the power minus 2 x square. Now we will expand this using binomial expansion, and this is actually an operator and it will operate on x square. See here, this is equal to e to the power 3x by 4 and the expansion is 1 minus 2 into d by 2 plus 3 into d2 by 4 minus 1 operating over x square. So it is equal to e to the power 3x by 4 x square minus this is 2 by 2 once. D is on x square means d means d by dx. So d by dx of x square is 2x plus 3 by 4 d2 differentiated twice with respect to x. So it will be 2. So it is equal to e to the power 3x by 4 x square minus 2x plus 3 by 2. This is our particular integral. Now the complete solution will be y is equal to complementary function plus particular integral. So it is c1 plus c2x e to the power x plus e to the power 3x by 4 into x square minus 2x plus 3 by 2. There is an example for you exercise d2 plus 1 y is equal to x into e to the power 2x. See here, this is also of the type e to the power ax into v. So you can solve it as our earlier problems. Next, now we come to our next topic. When the function x is of the type x to the power m into v, to find out the particular integral. See, if v is of the form e to the power ax, if this v is e to the power ax, then we can solve it by our just earlier method. And if v is of the form sin ax or cos ax, means your right hand side function x is x to the power sin ax or x to the power m cos ax, then we know that sin ax is the imaginary part in cos ax plus I sin ax, imaginary part, and this is your e to the power ix, and cos ax is the real part of this one. See here, cos ax, it is the real part of this complex number cos ax plus I sin ax. Therefore, particular integral of x to the power m sin ax will be imaginary part of the particular integral for x to the power m into e to the power iax, and particular integral of x to the power m cos ax will be real part of the particular integral for x to the power m e to the power iax. See here, you can see its solution by one example. It will be clear to you. Okay, before going to the example, see here one more type. When your capital X is of the type x into capital V, then 1 upon f dxv, 1 upon f dxv means particular integral. This will be written as x into 1 upon f dv plus d over dt. This is 1 upon fd, or you can say this is fd inverse. There is misprinting. It should be fd inverse over v. So it is equal to, this is the same, x into 1 upon f dv minus, when we differentiate 1 upon fd with respect to d, so it will be f dash d into 1 upon f dash d whole square v. It will be clear with an example. See here the example. Solve d2y by dx2 plus 4y is equal to x into sin x. Here the auxiliary equation will be m square plus 4 equal to 0. So m will be plus minus 2y, means it is complex function. Here alpha is 0 and beta is 2. So the complementary function is e to the power 0 into x within bracket a cos beta x plus b sin beta x. So it is a cos 2x plus b sin 2x. This is our complementary function. And the particular integral will be 1 upon d2 plus 4 x sin x. Now see, this is of the type x into sin x or x to the power m into sin x. M is 1 and a is 1. So this is calculated as particular integral in the imaginary part for 1 upon d2 plus 4 x e to the power iax, or imaginary part in 1 upon d2 plus 4 x e to the power iax. Now see, 1 upon d2 plus 4 x into e to the power iax, it can be written as 1 upon 4 I, and we will make its partial fraction. So it is 1 upon d minus 2i minus 1 upon d plus 2i x into e to the power ix. When you take its LCM, it will be d square plus 4. Here you come get 2i, here you get plus 2i. So both of them is 4i, 4i, 4i cancel. So it is the same as this one. So it can be written as 1 upon 4i e to the power ix into 1 upon, now this e to the power ix, e to the power ix into v type function this is. So take e to the power ix here. Then within bracket we have 1 upon d. D is replaced by d plus I. This I is the coefficient of x in e to the power ix. Minus 2i minus 1 upon d plus I plus 2i over x. So it is 1 upon 4i e to the power ix. 1 upon d minus I minus 1 upon d plus 3i x. So it is 1 upon 4i e to the power ix. See within bracket, take here I common, minus I common. So it is 1 upon minus I, 1 minus d by I, minus, take here 3i common, 1 upon 1 plus d by 3i over x. See, now this is equal to 1 upon 4i e to the power ix within bracket I into 1 minus d by I to the power minus 1 plus I by 3. 1 plus d by 3i to the power minus 1 over x. See here plus, earlier it was minus, but I is in the denominator. So minus 1 is I square. So I square by I is your I. So it is your plus sign. This is equal to 1/4 I to the power ix within bracket I. Now expand this using binomial expansion. So it is 1 plus d by I plus d square by I square plus 1 plus I by 3. Expand this also by binomial expansion. 1 minus d by 3i plus d square by 9i square minus 1 over x. So it is 1/4 I to the power ix within bracket I. Now this x goes here, x plus 1 upon I, and d is operating on x, so it is 1, and all other d2, d3, they will give 0, so no need to write here, plus I by 3. Now this is your x minus 1 upon 3i, d is operating on x, so it is 1, and d2, d3, d4, d4, all of them will give you 0, so no need to write here. So it is equal to 1/4 I cancels, it is power ix, x plus 1 by I plus 1 by 3, x minus 1 by 3i, it is 1/4 it is power ix. See here, this will be 1 upon I is your minus I. So it is x minus I plus 1 upon 3 x plus I by 3. See here minus 1. So it will be plus I square and I both cancel. So it is I by 3. So it is equal to 1/4 it is power ix within bracket. Takes here common. So x into 1 plus 1 by 3 plus I into 1 by 9 minus 1. So this is equal to 1/4 it is power ix. This is your 4 by 3, 4 by 3x minus 8 by 9i. It means it is for is 4 cancels, x by 3 minus 2i by 9, so it is equal to cos x plus I sin x, x by 3 minus 2 by 9i. Therefore imaginary part will be, take here the imaginary part will be what, I sin x into x by 3, so it is x by 3 sin x, and minus 2 by 9 cos x, minus 2 by 9 cos x. So this is our particular integral. Earlier we have evaluated complementary function. So the general solution will be y is equal to complementary function plus particular integral. See, the complete solution will be this one. Y is equal to a cos 2x plus b sin x plus x by 3 sin x minus 2 by 9 cos x. One more example is there, but it is the similar one. So you can solve it yourself. See here, d minus 1 whole square y is equal to x sin x. Here also the equation is m minus 1 whole square is equal to 0. So m will be 1 1. Both roots are equal. So it is complementary function will be c1 plus c2x e to the power x. And now you proceed as we did earlier. You can solve it very easily. And if you have any difficulty, you can call me, WhatsApp me, email me, or you can call me here also.